Hello, today we're going to be talking about the Central Limit Theorem, a fundamental concept in statistics that any stat student should know. First, let's look at this graph over here. And we have here some population distribution, the shape of which is not really known to us. So the squiggly line could go any way you can imagine, and for us it's all the same. We don't know the population mean or the population standard deviation. All we know is that it contains thousands, if not tens of thousands of possible observations, which nobody really has the time to or the capability to collect and infer from that the unknown values of our population mean or the population standard deviation. And this is a very frequent situation in statistics. Now, we have those huge populations that we kind of want to work with. However, there's no way a human or even a group of humans can have all of that information. So how do we deal with that uncertainty and this ignorance that we all have to face when we're talking about huge populations? And that's where the Central Limit Theorem really comes to our aid. Now, what the Central Limit Theorem tells us is that we don't have to know every observation in a population. We don't have to know the population mean or the population standard deviation. What we have to do is gather samples, and we need to gather enough samples. And when we have enough samples, it turns out that the sampling distribution, which is a theoretical distribution that you can see on your right, notice how the x in the original graph is now x hat, where it stands for the sample mean. So this collection of sample means that we're going to gather is going to be normally distributed regardless of the underlying population probability distribution function. And this is a really remarkable thing. So the squiggly line can go any way, and as long as we have enough samples, we're going to get the good old bell curve. And what's considered a large enough number of samples is usually 30 or more. So once you have those 30 samples, you have the bell curve and you can work with it. For example, the real significance of it is that you can take any sample from the population and you can estimate how far from the population mean it falls, since our sampling distribution mean, when we have enough samples, is going to approach the population mean. And the same can be said about the standard deviation of our sampling distribution. So this is really cool, since once you have 30 samples or more, you can now work with it and you can now infer things about a population or a given sample. And one of the things we like to do in statistics is to standardize things. And there's a formula, of course, to standardize any sample in a sampling distribution. So here is what it looks like. You have your z-score for your sample in a sampling distribution, and it's calculated like this. You have your sample mean, and you subtract from that the sampling distribution mean, and you divide that by the sampling distribution's standard deviation. And essentially what that equals to, if we assume that our sampling distribution mean equals to the population mean, and our standard deviation for the sampling distribution equals the population standard deviation divided by the square root of the number of observations that we have, we get a formula that looks like this. This is the relationship between the standard deviation of the sampling distribution and the standard deviation of a population, and it can be visualized somewhat like this. We have this bell curve over here. When we have, let's say, 15 observations, that becomes thinner and thinner and taller the more observations we have. So the bell curve becomes narrower and the standard deviation decreases as we increase the number of observations that we have. So as you can see, this is a very useful tool that allows you to work with your populations without actually gathering all of that information about the population and having to perform thousands, if not tens of thousands of observations. And this is very handy, and we're going to work with this in our future videos, which I hope you'll watch. But for now, that's it. Go through the material again. If you have any questions, ask us in the comments and we'll be happy to answer. And thank you for joining us today. Take care. Bye-bye.